Hello folks. So in this video we are continuing the whole AWS webinar for MySQL Aurora, and we are at provisioning DB cluster labs step. So this lab will walk you through the steps of creating an Amazon Aurora database cluster manually and configuring the app parameters required for the cluster components. I think this is the client apps or the MySQL itself. I'm not sure. So app parameters required for the cluster components. At the end of this lab, you'll have a database cluster ready to be used in subsequent labs. In my case, I can actually see, just a moment. So if I go here, or if I go to the dashboard, I can actually see already Aurora. There are some DB instances already available. DB instances and DB clusters. So I think this is the databases. Okay, what's the difference? Both says, okay, I just click this. I think this is the cluster and this is the node. So I think they don't differentiate between these two. So no reserved instances and all. There is some subnet group and there is there are some recent events. Cluster snapshot, automated cluster snapshot created. Okay, so you can actually see that there are already many clusters here. So Aurora Lab, MySQL cluster, serverless video cluster, standard storage, UPG. I think this is for upgrade. All right, and then backtrack. So let's look at this. So at the end of the lab, you'll have a database cluster ready to be used in subsequent labs. So now let's go ahead, create and configure Aurora provisioned cluster. This lab will walk you through the steps of creating an Amazon Aurora database cluster manually and configuring the parameters required for the cluster components. At the end of this lab, you'll have a database cluster ready to be used in subsequent labs. Same thing. So if you're familiar with the basic concepts, like do you already know how to create a database cluster? No, not on Amazon AWS, no. So especially the Aurora MySQL. So if you're familiar with the basic concepts of Amazon Aurora MySQL and have created a cluster in the past, you may skip this module by provisioning the lab environment using the option to have the DB cluster deployed automatically. In our case, it was deployed, that's why we have it. But see the get started prerequisites modules for detail on provisioning the lab environment. Skip to connect, load data, and auto scale. If you're running these labs in a formal organized workshop event, please follow the recommendations of your instructors and ask any lab assistant for help if you have any questions about this lab. So this lab contains the following tasks: create the DB cluster, create a replica auto scaling policy, clean up resources. So it requires these two. So let's go ahead and cool. So this lab will walk you through the steps of creating Amazon Aurora database cluster manually and configuring all the parameters required for the cluster components. So open the Amazon RDS service console, done, and click the create database. Okay, so here it is, create database. So relational database service, so makes it easy to set up, operate, and scale a relational database in the cloud. So you can use a new backup from Amazon S3 to restore and create a new Aurora MySQL and MySQL database. Okay, so we are creating a database and we are doing MySQL. So it's a standard create. Use recommended best practice configuration. Some configuration options can be changed after the database is created. You set all of the configuration options, including ones for availability, security, backups, and maintenance. So create a database. Set the following options on the configuration screen for the new database cluster. Standard create. So in the choose a database creation method, standard create, ensure this is selected. Yep. In the engine options section, choose the Aurora MySQL compatible engine type. Yep. MySQL compatible. Another one is Postgres compatible. The other one is MySQL itself, not Aurora. This is MySQL compatible but not MySQL. So Postgres and then MariaDB, which is the fork of MySQL, and then Oracle DB, and then IBM DB2, and then Microsoft SQL Server. So select the Aurora MySQL 3.06 compatible with 8.034 version. So this is Aurora MySQL 3.060. So we are going to choose 3.060, which is compatible with the open source MySQL 8.03, 0.34. Okay, so we have done that. We are not going to choose extended support, I guess. It's a paid offering. By selecting this option, you consent to being charged for this offering. If you're running your database major version past the RDS end of standard support date for that version. Check the end for your major version standard support date for your major version in Amazon Aurora documentation. Okay. Templates, will be choosing production. Okay, so production use defaults for high availability and fast consistent performance. This instance is intended for development use outside of a production environment, say for development, testing and all that, so staging and stuff like that. I think staging may be production for nightly and dev environment and all. So DB cluster identifiers, so enter a name for your database cluster. So the name must be unique across all database clusters owned by your AWS account in the current AWS region. Okay, so we'll be using Aurora DB, Aurora Lab Manual as the name. So it can't have hyphens at the end. So DB cluster must not have either two consecutive hyphens or hyphen at the end. So you can't have two consecutive hyphens like this. Like one hyphen is fine. Two consecutive hyphens you can't have, and at the end also you can't have. Like for example, like this. So the DB cluster identifier is case sensitive, but it is stored as all lowercase, as in my DB cluster constraint. So it's stored all lowercase. So constraints 1 to 63 alphanumerical characters. So you can have numeric characters also, or hyphens. First character must be a letter, can't contain two consecutive hyphens, can't end with a hyphen. Cool. So credential settings, you set the master username to administrator. So I'll do that. And this is the user account with the most elevated permissions. In the database, you can use a different name, but may need to edit commands in subsequent labs. Okay, so I'll just use the same name. You can use different name. So it has most elevated permissions, kind of like the root username. So you can use a different name, but may need to edit commands in subsequent labs. Under credentials management, select self-managed. If it's managed in AWS Secrets Manager, okay, you can use AWS Secrets Manager or manage your master user credentials. RDS generates a password for you and manages it through its life cycle using AWS Secrets Manager. Create your own password or have RDS create a password that you manage. So you can either say auto generate. You can view your credentials after you create your database. Click the view credential details in the database creation banner to view the password. Can generate a password for you, or you can specify your own password. So I will specify my own password. So ensure the checkbox order is not checked. So auto generate password, you don't auto generate. So instead you type your password, set the password to a desired memorable value. So let me type in the password. Okay, cool. Passwords don't match. Great. Okay, wait. Okay, so cool. So now in the cluster storage configuration, select Aurora standard. Okay, choose Aurora. Choose the storage configuration for the Aurora DB cluster. Okay, storage configuration, what is this? Okay, I think they have a lot of information here, tutorials and stuff. Okay, so for the Aurora DB cluster that best fits your application's price predictability and price performance needs. So configuration options, database instance, storage and input output charges may vary depending on the configuration. Okay, so Aurora input output optimize Aurora standard. So predictable pricing for all applications, improved price performance. I guess this is about the ratio, price performance ratio, how much price you pay and what is the performance you get. Low price and good performance. So for input output intensive applications, input output cost is greater than 25% of total database costs. No additional charges for read-write input-output operations. DB instance and storage prices include input-output usage. Standard cost-effective pricing for many applications with moderate I/O usage. Input-output costs is less than 25% of total database costs. Pay per request, input output charges apply. DB instance and storage prices don't include IO usage. Okay, cool. So there are different stuff. So let's choosing Aurora standard for now, and then instance configuration, memory optimized classes, and choose R6G large in the drop. Say okay, memory optimized, yes. Here we choose R6 DB dot R6G large. Okay, availability and durability, create an Aurora replica or reader node in a different availability zone. Yeah, recommended for scaled availability, creates an Aurora replica for fast failover and high availability. Don't create an Aurora replica. Okay, this is serverless v2 burstable classes. Okay, there are T classes, includes R classes. Okay, so with that in place, these are like pretty big, huh? 1000 GB RAM, 1024 GB RAM. This one is basically 16 GB RAM and 2 vCPUs. This is 16 4 virtual CPUs. Anyways, cool. So now we have these done. Okay, in the connectivity section, don't connect to an EC2 compute resource value for compute resource. Okay, don't connect to an EC2. Okay, so choose whether to set up a connection to a compute resource for this database. Setting up a connection will automatically change connectivity settings so that the compute resource can connect to the database. Okay, don't connect to an EC2 compute resource. Don't set up a connection to a compute resource for this database. You can manually set up a connection to a compute resource later. Set up a connection to an EC2 compute resource for this database. Connect. Okay, IPv4 dual stack mode. This is your resources can communicate over IPv version 4 and version 6. This is 32-bit. I think this is 128-bit or something, and then or both. So your resources can communicate only over the IPv4 addressing protocol. Should we go with IPv4? Yeah. So to use dual stack, make sure that you associate an IPv6 CIDR block with a subnet in the VPC you specify. Okay. VPC, pick the virtual private cloud named Aurora Lab VPC. Okay. So it should be called Aurora, not the default VPC, but the Aurora Lab VPC, which has 6 subnets and 3 availability zones. So the VPC defines the virtual networking environment for the TCP cluster. Okay, and the database subnet group will be selected automatically once you choose the right VPC. So please verify the selection is correct. The name of the database subnet group should be Aurora Lab DB subnet group. Yep. If it is default, it goes to default something, but for this there's only one. Yeah, in this VPC I think there's only one subnet. Oops, I clicked public access. I think it should be no. Let's see. So choose the DB subnet group, defines which subnets and IP ranges of the database cluster can use in the VPC that you selected. Okay, so select no for public access. Yep, done. RDS doesn't assign a public IP address to the cluster. Only Amazon EC2 instances and other resources inside the VPC can connect to your cluster. So choose one or more VPC security groups that specify which resources can connect to the cluster. Great. It assigns IP like public IP address if you say a public access is true, like yes. Amazon EC2 instances and other resources outside of the VPC can connect to your cluster. Resources inside the can also connect to the cluster. Choose one or more users. That's which resources can. Okay. So VPC security group firewall. Make sure you choose the existing security group option is enabled. The lab environment already provides a security group that allows your lab workspace EC2 instance to connect to the database. Okay. So choose existing and okay, select the security group named Aurora Database SG. Okay, I think we can remove this and we can say Aurora Database SG. Okay, and please remove any other security groups such as default from the selection. Okay, I think we are good. In the database authentication, choose IAM database authentication. IAM authentication may be used in some of the subsequent labs. In the monitoring section, okay, so RDS proxy is a fully managed, highly available database proxy that improves application scalability, resiliency, and security. Creates an IAM role and a secrets manager for the proxy. As additional costs. Certificate authority, okay. So these, they have not mentioned anything about these. So additional configuration, nothing. Certificate authority. RDS certificate authority 2048. Okay. RSA is what if by default it's chosen. Okay. Using a server certificate provides an extra layer of security by validating that the connection is being made to an Amazon database. It does so by checking the server certificate that it is automatically installed on all databases that you provision. So it's basically, I think this is a certificate for secure connectivity. So it's secured, TCP secured. Okay. Secure sockets layer, SSL or TLS, transport layer security. So read replica write forwarding, I don't think we're doing that. So IAM authentication, this is about issue write operations from a reader DB instance within the same DB cluster. Okay. Tags, nothing. So IAM based authentication, Kerberos, nope. Authenticates using Kerberos, authentication using through an AWS directory service for Microsoft Active Directory AD. Okay. Authenticate using IAM database authentication. Password authentication is always active for a database engine. You can also turn on additional authentication methods for your database below. And then there is database insights, advanced and standard. So turn on performance insights. So you have choose monitoring tools for this database. Database insights provides a combined view of performance. So this is database insights, which is a combined view of performance insights and enhanced monitoring for your fleet of databases. Database insights pricing is separate from RDS monthly estimates. So it retains 15 months of performance history. This one is retains 7 days of performance history. Fleet level monitoring, this is pay for the retention of up to 24 months. So you can pay for retention. Okay. Integration with CloudWatch application signals. I'm not sure what that is exactly, but okay. With performance insights dashboard, you can visualize the database load on your Amazon RDS database instance load and filter the load by weights, SQL statements, hosts or users. Retention period 15 months. Okay, key management system key, so KMS key. Retention period of default 7 days. I think we can't choose the retention period mostly because okay, so I think we might have to choose this and not this, and 7 days, and then master key default AWS RDS. Expand additional configuration. Okay, so this is RDS, additional monitoring configuration, enable enhanced monitoring, is it? Yeah, check the enable. Select a granularity of 1 second. Okay. Okay, OS metrics granularity is 1 second, is it? Okay, monitoring. So this is a bit old, I think. So select Aurora lab monitor region name value monitoring role. For example, role would be named US West 2 if you are running the lab in US West 2. I think we are doing US West 2, yeah. Let me see, yeah, Oregon, US West 2. So, yep. Enhanced monitoring, CloudWatch logs and DevOps Guru. Okay, enhanced monitoring. Okay, if you remove this, log exports. Okay, and you have log exports. However, okay. Enabling enhanced monitoring metrics are useful when you want to see how different processes or threads use the CPU. Okay. So logs. I mean, this one you've done. We've selected the monitoring role. We'll create it with authorize RDS to create the IAM role, RDS monitoring role. Okay. We're done. Expand the additional configuration section and configure options as below. Okay. So initial database name, my lab. You can use a custom name here too, but you will need to edit commands and scripts in subsequent labs. Okay, I'll just put my lab then. So database cluster parameter group selector, choose the groups named starting with Aurora lab. Okay. Cluster 3, there are 2 of them. Cluster 3 BK, is it? Okay, 3 hyphen. Cluster params 3 hyphen. So Aurora lab CPG cluster params 3 hyphen. Okay. And then leave database parameter group to the default value. Okay. So what are these? If you do not specify, does not create a database. Okay. Parameter group associated with this instance. Okay, option group. So set backup retention period to 1 day. Okay, 1 day. Yep. You can have till 35 days. Okay. For which automatic backups are kept. Okay. Automatic backups, we are keeping it only for 1 day. Check the box to enable encryption. Okay. Copy tags to snapshots. Yeah, it's already there. Continuing in the for log experts, check the error log and slow query logs. Okay. So here error log and slow query log. You don't want the others. IMDb auth error, instance log. Okay, audit log. Okay, so these came up before itself, and then deselect or turn off the checkbox enable delete protection. In a production use case, you will want to leave that option checked, but for testing purposes, unchecking the norm will make it easier to clean up the resources once you've completed the labs. So so enable backtrack, we'll come to these. Protects the database from being deleted accidentally. While this option is enabled, you can't delete the database. You're going to backtrack soon. No, backtrack stuff didn't come up, huh? Interesting. Backtrack. Okay. Just wondering, enable backtrack has not been enabled. Okay, let's you quickly rewind the database cluster to a specific point in time. So it's like point in time recovery, I think. So rewind without having to create another database, another DB cluster. It'll charge you for storing the changes you make for backtracking. Okay, so yep, that's the same thing. Auto minor version upgrade, enable auto minor version upgrade. Enabling auto will automatically upgrade a database minor version. For implementations and more details, maintenance window, no preference, select the pending modifications or maintenance applied to a database. Okay, maybe I will not do, I think upgrades we have a separate thing, so I'll just do this and go ahead and create. So you're responsible. Okay, cool. So this should be creating. Okay, suggested add-ons for Aurora Lab manual. Okay, the thing that I created. Simplify the configuration of the following suggested add-ons by using settings from your new database. Create an elastic cache cluster from RDS using the DB settings new. So you can save cost and improve read performance by using elastic cache with RDS versus running an RDS alone. For example, you can save up to 80% 80x faster read performance using elastic cache with RDS for MySQL versus RDS for MySQL alone. So using a proxy allows your applications to pool and share database connections to help them scale. Simplifies connection management and makes application more resilient to database layers. Okay. And sessions, so they don't appear up to date. All these actions can be taken from the database list. Cool. So where is my Aurora Lab manual? It's here. So it's creating basically. So this is the reader instance. This is also a reader instance. Interesting. There's no writer instance yet. Okay. So it's a regional cluster, and yep, it's getting created. Let's refresh to see. Okay, so this is a writer instance now. Okay, so now we are done. Create a replica auto scaling policy. Okay, so 1 and then 2D. Okay, so finally you will add a read replica auto scaling. One moment, they have a lot of interesting stuff here. I don't know if I'll have time for this because this will get over in some time. It's okay. So you'll add a read replica auto scaling configuration to the database cluster. Okay, this will allow the database cluster to scale the number of reader DB instances that operate in the DB cluster at any given point in time based on the load. So based on the load, it will auto scale. I don't know if it will downscale, but okay, in the top right corner of the details cluster, click on actions and add. Okay, so actions, this one, create data restoring from. Okay, actions. Okay, I'm not able to do anything. I think this is for I have to click this and then yeah, activity stream, stop temporarily, migrate data. Okay, there are a lot of interesting things. Cross region read replica. So and then migrate, restore, add replica auto scaling. Here it is. So add auto scaling policy. Okay. Set the policy name based on the stack name Aurora auto scale manual. Okay. And then for the target metric, choose average CPU utilization. The target metric, choose average CPU utilization of Aurora replicas. So average CPU utilization of the Aurora replicas. Connections, more connections, target value accordingly based on what you'll scale, right? This is based on CPU. When the CPU utilization goes high, so enter a target value of 30%. In a production use case, this value may need to be set much higher, but we are using a lower value for demonstration purposes. So when it hits 30%, it will start auto scaling. So next, expand the additional configuration and change the scale. Change both the scale in cooldown period and scale in cooldown period and scale out cooldown period to a value of 180 seconds. Okay, so this is 30%. Scale in cooldown period, scale in, scale out. Enable to allow this auto scaling to remove Aurora replicas created by you are not removed by auto scaling. Okay, so auto scaled one, so 180 seconds is basically divided by 60 seconds, it's like 3 minutes. So this will reduce the time you have to wait between scaling operations in subsequent labs. In the cluster capacity details, set the minimum capacity to 1 and maximum capacity to 2. Okay, 1 and maximum to 2. So maximum 2 Aurora replicas, minimum 1. And in a production use case, you may need to use different values, but for demonstration purposes and to limit the cost associated with the labs, you limit the number of readers to 2. Next, click add policy. Okay, cool. So let's click add policy. Okay, cool, it's done. Right, clean up DB cluster resources. Do not forget to clean the delete the cluster. So the lab you went through was meant to give you hands-on experience of building an Aurora MySQL cluster. Now that you have built one, you can go ahead and delete it. We have pre-created a cluster for you that we will use for the rest of the labs. This makes sure we can write the instructions that match the screenshots and avoid any confusion while following the labs. We want you to delete the cluster to make sure the rest of the lab instructions don't intrude with the cluster you manually created. To make sure the rest of the don't manually created. Execute the following Python script which will delete the Aurora cluster you created. The command below assumes you use Aurora lab manual as your cluster name. If you use a different name, please replace the value of the cluster name parameter with the cluster name. So I think this will do it. I think we have to run this here. The delete cluster, these people have it over here. So basically it says JSON, time, pickle, and then boto3, argparse and all that. And passes arguments, takes cluster name, default is Aurora DB lab manual cluster. Process arguments, get the current region, get the cluster name, get the RDS client using boto3 Python package, and then for this region is by default. I think it's whatever region you're in here. I think this is actually just US West. So client error doesn't exist. Please provide correct cluster name and all. So response, describe DB clusters, you get the cluster name again, delete all the instances. So you describe and then, okay, so response, DB cluster members, deleting. So you have different instances within the DB cluster. So it will deleting this and then it will say delete DB instance identifier, skip final snapshot true, delete automated backups true. Okay. Cool, now let's run this. Python delete cluster name this. Yep, it has deleted. So as you can see, deleting, and this should show up here. Yeah, deleting. So in some time this should be deleted. Cool. Now let's go ahead with the next one. Gather prerequisites, do not skip. You'll gather values for the items needed throughout the labs, such as cluster endpoint and reader endpoint. You'll complete the following labs in this section. Retrieve the DB cluster endpoints, retrieve the networking information. Okay. DB cluster endpoints. In order to connect to the DB cluster and start using it in subsequent labs, you need to retrieve the DB cluster endpoints. There are two endpoints created by the default. Cluster endpoint will always point to the writer DB instance of the cluster and should be used for both writes and reads. The reader endpoint will always resolve to one of the reader DB instances and should be used to offload read operations to read replicas. In the RDS console, go to the DB cluster detail view by clicking the DB cluster DB identifier. So Aurora MySQL cluster, I think. This should be, it says deleting. I think it'll take some time. So backtrack cluster, IO optimized. I think this is the one we're looking at. So MySQL cluster, Aurora lab MySQL cluster, right? Interesting. If you click it, it goes up again, and click it again, and then it will unselected, I think. Okay, cool. So the endpoint section in the connectivity and security. So we have to actually open up something, I think. Wait. So go to the cluster detail view by clicking on the cluster DB identifier. How do I think I have to click this. Okay. Well, I clicked it. So I've opened it up, and the endpoint section in the connectivity and security tab of the details page displays the endpoints. Note these values down as you will use them later. Okay. So I think it's this and this endpoint name. This is okay. Aurora lab MySQL cluster. This is okay. This is read only RO. Okay. So this, let me just create a new file here. Info.txt, and I'll just put this here. Writer, reader, or read only is this. Okay. And cool. So we have these two. And retrieve security group and subnet group values. You'll find the values for DB security group and DB subnet group. Okay, in the stack, right? So we'll use the values in the later labs. Navigate to the cloud. Okay, so in a cloud formation, we're looking at DB security group and subnet group. Cool. So I can just copy this and say this. DB security group is this, and DB subnet group, if I want, is this. DB security group. Just to understand that this is the thing. So now we have that. Ensure you're still logging in the correct region, especially if you're following the links above to open the service console at the right screen. Okay. Okay, click the Aurora lab, and yep, I've got it. So I think you can get it even from the main page of this, where you can actually see the event outputs, and here you can see the DB, DB security group and stuff. So yeah, it tells which stack and all that. So I think we have used only one stack over here. Cool. Okay, so got that. I'm actually gonna break here and I'll continue in some time. There are still a lot of stuff pending. We'll do more things. So that's all I had for this video. I'll continue more once I get to the other stuff. Cool, that's all I had for this video. See you on the next one. Bye bye.